When Christopher Nolan's Interstellar first came out, it felt different, right? I mean, this wasn't your typical space opera with laser battles and aliens. Nope. This was a massive blockbuster that was built from the ground up on some seriously real, mind-bending physics, thanks to the help of Nobel Prize-winning physicist Kip Thorne himself. And they were not shy about it either. The entire marketing campaign was all about the scientific realism of the story. The whole pitch was, hey, you're not just watching some made-up fantasy. You're getting a peek into the actual wild possibilities of our universe. We're talking cosmic shortcuts, the crazy warping of time, the whole deal. So that brings us to the big question, doesn't it? Just how much of it was legit? We all know Interstellar is this incredible dance between rock-solid science, some really smart, educated guesses, and of course, a little bit of that Hollywood movie magic. So today, let's pull back the curtain and really figure out where the physics ends and the fiction begins. All right, let's start right where the movie does, with that galactic shortcut. The crew's entire mission hinges on this mysterious wormhole that, super conveniently, just shows up near Saturn, offering a one-way ticket to a whole new galaxy. Okay, so first things first, the idea of a wormhole, totally not just movie magic. This is a real, honest-to-goodness theoretical possibility that comes straight out of the math of Einstein's theory of general relativity. Think of it like a cosmic bridge connecting two super distant points in space-time. On paper, the math actually works. But, and this is a huge but, there's a massive gap between what the theory says and what we see on screen. See, our best understanding is that any real wormhole would be incredibly unstable. We're talking microscopic, and it would slam shut in an instant. No way you're flying a spaceship through that. Now, the filmmakers knew this, so they made a really clever sci-fi jump. Their wormhole, they say, was artificially built and held open by something called exotic matter. Just think of it as a theoretical substance with anti-gravity. It pushes space-time apart instead of pulling it together. And the coolest part? This is a concept Kip Thorne himself has actually worked on, which gives it this awesome stamp of scientific plausibility. So, they make it through the wormhole and find themselves in a star system that is just, well, it's unlike anything we can imagine. Everything there orbits one single, terrifying thing, a supermassive black hole they call Gargantua. And this is where the laws of physics don't just get bent, they get pushed right to the absolute breaking point. First off, let's just try to wrap our heads around the scale here. Gargantua has the mass of 100 million suns. And get this, that's not science fiction. That part is absolutely spot on. We know for a fact that monster black holes like this exist. They're the anchors at the center of most galaxies, including our own Milky Way. And a black hole that big leads to one of the most heartbreaking parts of the entire movie, time dilation. I mean, on that first water planet, for every hour they spend down there, 7 years go by for the guy they left in orbit. And the wildest thing is, time dilation is real. Gravity literally slows down time. But a time slip that huge, that is pushing the science to its absolute limit. So how did they justify it? Well, it turns out this whole 1 hour equals 7 years thing was a non-negotiable from the director, Christopher Nolan. He needed it for the story. So Kip Thorne had to go back to the drawing board to make the math work. And the solution he came up with? Gargantua had to be spinning, like, ridiculously fast. We're talking so close to the cosmic speed limit that its edge is practically moving at the speed of light. That was the only way to get enough gravitational pull to warp time that dramatically.
But the messed up time wasn't the only problem on Miller's planet, was it? Remember those waves? Those absolutely enormous, mountain-sized tidal waves. It's one of the most terrifying scenes in the movie. But it makes you wonder, in a gravitational field that extreme, could waves like that even form in the first place?
The short answer? Absolutely not. The tidal forces from Gargantua would be so insane, so powerful, that the planet would become tidally locked almost instantly, like in a millisecond. That means its rotation would just stop relative to the black hole. So instead of these massive rolling waves, you just get one giant permanent bulge of water, frozen in place, constantly being pulled towards Gargantua. Way less dramatic for sure. Okay, so let's move on from the planets for a minute and talk about the real star of the show, Gargantua itself. Because the way they visualized this black hole wasn't just cool looking, it was a legitimate scientific achievement. It gave us the first truly realistic picture of what a black hole would actually look like. And this, right here, is where the movie absolutely nailed it. What we're seeing is a real phenomenon called gravitational lensing. Basically, Gargantua's gravity is so powerful it literally bends the path of light, just like a lens. The visual effects team actually used Kip Thorne's own equations to map out how the light from the glowing gas behind the black hole would get warped up and over the top and down and under the bottom. That's how they created that incredible, iconic halo. Just a stunning piece of work. But they did make one pretty big change for the sake of art. In reality, that beautiful, glowing ring wouldn't look so perfectly symmetrical. Because all that gas is spinning at nearly the speed of light, you'd get a massive Doppler effect. So the side spinning towards you would be super bright and bluish, while the side spinning away from you would be much dimmer and reddish. The whole thing would look really lopsided.
So why'd they change it? Well, it was a totally conscious decision. Apparently the director, Nolan, felt that a scientifically perfect, lopsided image would just be, well, confusing for most people. So they decided to sacrifice that little bit of scientific accuracy to create an image that was powerful, easy to understand, and totally unforgettable.
All right, this brings us to the grand finale of the film. And it all comes down to two huge scientific ideas. First, that insane escape maneuver from Gargantua's gravity well. And second, Cooper's final journey, falling past the point of no return. Let's talk about that slingshot maneuver first. You know, the one they used to escape Gargantua. It looks like something straight out of a crazy action movie, but you're not going to believe this. It's actually based on one of the most mind-bending and scientifically accurate concepts in the entire film. Yeah, it's a real thing called the Penrose process. So a spinning black hole literally drags space-time along with it in a zone called the ergosphere. If you fly into that zone and drop something into the black hole against its spin, the black hole basically transfers some of its rotational energy to you. You get flung out with way more speed and energy than you came in with. I mean, think about that for a second. It's a way to literally steal energy from a black hole's spin. Just wow. An amazing bit of real science right there. But then, Cooper detaches. He falls into Gargantua. And at this exact moment, the movie takes its biggest leap yet. We are officially leaving the world of established, proven physics, and we're crossing over into the wild, fascinating frontier of pure, unproven theory. Everything he finds in there, the Tesseract, the whole idea of a five-dimensional universe, using gravity to send messages back in time, all of it comes from the absolute bleeding edge of theoretical physics. We're talking about mind-bending ideas like M-theory and the search for a theory of everything. This isn't science fact, not at all. This is the movie asking a beautiful, profound scientific question. What if? So in the end, Interstellar is just this incredible balancing act, isn't it? It bent the rules of physics when it needed to for the story, but at the same time, it gave us some of the most beautiful and accurate science we've ever seen in a movie. It really proved that a great story can be the perfect way to explore even greater scientific ideas. And it just leaves you wondering, right? What scientific impossibility is out there right now, just waiting for the next great filmmaker to come along and make us all believe it's real?